Hello everyone. In this lecture, we're going to talk about anomaly detection. So there is a common misconception between two concepts, outliers and anomalies. So in general, you will see that a lot of people will say these two words as synonyms, which is fine for some context, but the anomaly idea is broader than the outlier idea or concept. So let's say that outliers are typically found or detected when you are pre-processing your data, pretty much when you're analyzing a single column. So let's say you have a table with multiple columns and you start looking for extreme values, like high values or small values in each column. So it's more like a one-dimension analysis, the outlier detection. And you typically use z-scores, some box plots, right, to find those outliers. However, the anomaly concept, it's bigger than that. It involves more things. It's not just about high or small values. It also provides context. The context is important when we're talking about anomalies. So let's say that outliers are a special case of anomalies. That's true. But anomaly, the idea of anomaly, it's broader than the word outlier. So we cannot use the one or the other as synonyms in general. So let me show you an example. So typically, let's say in the first plot here, this one. So an outlier will be, we have two variables, x1 and x2. So an outlier for x2 will be, something that is in this region, right? It's like a high value. Or for x1, you have a small value, let's say located in this area, right? So this is a small value, it's an outlier. Now, let's see an anomaly, which is an observation that deviates from the expected pattern. So here in this plot, we have a pattern, right? Now, if you see this point here, and you analyze the coordinates x1 and x2, please notice that x1, this is not the smallest value. There are smaller values, for x1. And in the case of x2, same thing, it's like within range. But when you combine and when you compare with the pattern, you see that this point is isolated. Even though, again, it doesn't have like a high value or small value for x1 and x2. The problem is it doesn't follow the pattern. So it's considered an anomaly. So for that, this is to show you the difference between outlier and anomaly. So this is not just for numerical variables. So you may have a network, for example, and we're labeling our nodes. And if you get a label that is like different to the neighbors, so maybe that's an anomaly behavior, right? So you need to analyze and understand this node better. With the time series, sometimes we have time intervals with a different pattern with different values. So here we have like a cyclical pattern, right? But in this specific time interval, it changes, right? So this is an anomaly here, right? And we need to detect it and understand what's happening. A similar idea when you're dealing with text. So there may be some changes, right? Let's say here there is a portion of the text where we have words that are longer compared to, like the rest of the text. So that's an anomaly here in this context. So anomaly is not just for one variable, like with outliers. It's for multivariate analysis. And it's not just for numerical variables. You can do it also in different contexts, using text, time series, network structures, images, right? So it's a way more broad concept compared to outliers. So let's go over some types of anomalies. So this is the most popular one, point, the point anomaly. It's like an outlier, right? It's a single data point that is different from the rest. So you have, like if you have some sensors and you register an unusual value, like someone that is really high or really low, then that will be, of course, an anomaly. So some examples are infrared detection, right, and sensors, as I just mentioned. Now, the second type, it's contextual anomalies. So these are points that the value is not an anomaly. Now, depending on the context, it will be considered an anomaly. Let me give you an example. Let's say that you are analyzing the web traffic. So if at 3 a.m. you have the same like traffic that at 8 p.m. So even though the value is normal at 8 p.m., the same value is going to be considered an anomaly at 3 a.m. Right? So the context matters. So this is what you see here. So this is the context, right? So this value, I mean, you can see this value at different times, but in this specific context, 3 a.m., it's unusual, right? It's an anomaly. Okay, let's see more anomaly types. Collective. So this is when a single point it's normal, but when you have several points together, that group it's an anomaly. An example of this, let's say that there is a login attempt, right? So maybe a normal login attempt. But now, if there are several login attempts, like a group of observations, then in a short time, that's an anomaly. So a single login attempt is not, it might happen, right? It's normal. But when we have like several of these login attempts, that now it's a collective anomaly. So this is very common, of course, in cybersecurity, network traffic. Temporal anomalies refer to time series. You might have like a window, like a time window, where there are some unusual observations. So let's say that you're experiencing some sensor readings that are, like weird compared to the other values during a 10-minute window. So that's a temporal anomaly. And spatial anomalies, these are based on location. For example, remember when you change, let's say that you're trying to access your email from a different device, different cell phone or different computer or different location. So you might get like a warning, right? Because it's considered atypical because the location is changing. So this is very common, of course, in geospatial data, environmental monitoring. There are different tools and techniques to identify anomalies. So the most popular techniques are statistical baselines. So I'm sure that you have used z-scores. So the idea is like values, like inside -3 and 3 standard deviations, from the mean. These are normal values. If you have values outside, lower than -3 or greater than 3, then you will have an outlier in that case or an anomaly. We have distance and density techniques. We'll see DV-scan for that. Isolation based, such as the isolation forest, which we will cover also in this lecture, and in the video there will be a walkthrough, the code to use isolation forest. We have one class is SVM. It identifies, it's like a classifier that finds one class, which is like the normal observation. So if there is a new observation and it cannot be classified as normal, as the previous known values, then it's considered as an outlier or an atypical value in this context, anomaly. A change point, we have seen some of these in time series, right, when there are some changes. And when you have streaming scenarios, where there is online data arriving into your data set, then there are some techniques that are special to handle and identify anomalies in this context. Sometimes you will see even the same algorithms like isolation forest, but adapted for an online environment. Okay, so let's discuss some of these techniques. So the statistical baselines, again, these are very popular during the pre-processing stage in a end-to-end machine learning process. So z-scores allow you to find, and per column you find, for per numerical value, you find a variable that is z. And the nice thing about z is that the mean value of z is equal to 0. and the standard deviation of z is equal to 1, right? So you don't have units here. That's why you create this rule. It's like if you have values that are, like above 3 or below -3, then that's an indication of anomaly or outlier, right? So typically you will use the box plot. That's very common. I'm pretty sure that you have seen it before where, like we have the whiskers of the box plot, and if there are observations above the whisker or below the whisker, that means that that's an outlier or an anomaly in this context. Okay, the interquartile range, it's a similar technique or tool. So here we define the IQR, it's the distance between the Q3 and Q1, the quartiles, the third quartile and the first quartile. And we define a specific interval. So this is how we get these whiskers, right? So everything that is outside this distance, right, given by these whiskers, then is going to be considered an outlier or an anomaly. So I'm pretty sure that most of you are familiar with these techniques. So now let's check some different concepts that might help you to identify anomalies. So DB-scan, this is originally this is a clustering technique, to find groups in your data. It's an unsupervised learning technique. So, but it's really interesting. The DB-scan, it works by looking points that are like together. So it requires two parameters. You need epsilon, which is the radius of search of neighboring points, and the minimum number of points. So just let me give you an idea. So let's say that you position, your attention in this point, in the X here, right? So the epsilon is going to create like a radius here. So imagine like a circle around that point, right? Now, if the minimum number of points, which is the second parameter, are included in this circle, in this region, then that point belongs to that cluster. It can be assigned to that cluster. Now, if that point it's close, or in the circle you have other points that are part of a cluster, so that's considered a border point. So this is when you don't meet the requirement of the minimum points, but there is still one point that belongs to a cluster. Now, in some cases, like let's say, let me show you this point here. If you have the circle, with the epsilon, you don't meet the requirement of the minimum points. You don't meet that requirement, and there are not even other points that are part of a cluster. So in that case, that's considered a noise point. So if you see this example, please notice that we have here two clusters, right? So in the inner area, that's the core points. Now there is like a lighter color area, that's the border points, and the points that they don't have a color, that means that they are considered noise, or in our context, that will be an anomaly. So these points are anomalies here. And the points in the light area, they might be considered like potentially anomalous values. So we need to check them too. But for sure, this noise, it's most of the time it's considered anomalies, right? Because they don't belong they don't have, like a similar pattern to the rest of the data. So this is a really useful technique, DB-scan, a clustering technique. There are some isolation-based techniques. So they use, the most popular one is the isolation forest. So it's imagine like a decision tree, regressor or classifier. So the intuition is simple. So let's say you have your data. So this is like a two-dimensional example, x1 and x2, and you have your observations. So the way in which the isolation forest works is that it will try to isolate the points. So it's going to create partitions to isolate the points, right, from the other observations. So in this case, for this point, with a single partition, you can say like x2, right, greater to, a specific value. Let's say that this is like 100, so x2 greater than 100, and you have an isolation, right? Now, if you try to do something with a point that is surrounded but similar point, you will need more partitions. you will need more splits. For example, here you need different splits. So that means that this is a normal point. But if you need like very few splits or partitions, then that point most likely it's an anomaly. So this is the idea of the isolation forest. So you have multiple trees. For example, for this observation, you can isolate it only with a single partition. So the red points are anomalies for sure. And these points here at the bottom, they are most likely normal instances or normal observations because you need several partitions of the variables to isolate. Like here, for example, you need like 4 partitions, right? To be able to isolate that point. So that's the idea behind this algorithm. There will be another video where I will show you, the coding of this algorithm, which is you will find it in scikit-learn. There are some streaming or online techniques. So there is a popular library in Python, River. River library is for online machine learning. So online means that you have like streams of data. So it's not like you have, your tables right away. No, in the online setting means that you're getting your data as a flow of information arriving. So you need to train your models, right, to be able to capture that data. And same idea with anomaly. You need some algorithms to identify anomalies when you have this context, right? So what we will find here is that there are some like window baselines. And of course, we will find some shifts in the, like, what is the mean value of previous observations and now what is the mean value of the new information arriving. So it's like, imagine like some inference analysis, but of course a little bit more sophisticated depending on the algorithm that you are using. And there are some variations of the isolation forest for the online context. So now to summarize this lecture, so there are multiple techniques that we can use to identify anomalies. So some of them are simple statistical baselines, but again, these are mainly for a single variable. So they are mainly for outliers, right? But when you have like multiple variables and you want to identify patterns and learn, then these techniques are not good for that. You will need some advanced, machine learning techniques where they have more learning. They identify the pattern in your data and they are multivariate. So that's where you have the isolation forest or DB scan, for example. These are examples of techniques that, like identify the patterns in your data to judge whether an observation is an anomaly or not. So the choice of the method will depend, of course, of our context, whether detection needs to be real time or if it's offline, right, or batch based. Remember, and this is really important, outliers are a type of anomaly, but they are not like exactly the same. The anomaly concept is broader than the outlier concept, right? Because they depend not just on the values, they also depend on the context, right, and other observations. While outliers typically are seen as individual values, right, that are, like different. So typically it's more for like one dimension or one variable analysis. Okay, so these techniques are really important because they will allow you to filter your data, to like to get what is really relevant. When you're training a model, sometimes the anomaly information may affect your training. So it is important to detect them and also to understand where you're getting, those anomaly values. Okay, I'll see you in the next lecture.